Hey, we're starting simplification of expressions and simplifying algebraic expressions, radical expressions, and what you need to know on every one of these is what I have written here. If you're adding, subtracting anything, they have to be alike. If you're multiplying, dividing, you can multiply and divide anything, okay? But you can only add and subtract things that are alike. Notice here these radicals are not alike. So therefore, in order to be able to add or subtract them, we would have to somehow make them alike. And we've done this in the past. Square root of 18, I know 18 is 9 times 2. The square root of 50, I know that 55 is 25 times 2. If you know any square roots, you can bring it on the outside. So that's going to be now 3 root 2. And then the square root of 25 is 5. So what you're adding now is 3 root 2 plus 5 root 2. If things are alike, they can be added. 3 root 2s plus 5 root 2s, we're only going to add the coefficients. The rest of it stays alike. 8, leave the root 2 alone. So again, addition, subtraction has to be alike. Let's try another one. So here you got square root of 9 times 7 plus the square root of 8, which is 4 times 2, plus these parentheses are really not necessary. Square root of 28 is 7 times 4, and the square root of 50 is 25 times 2. Let's clean it up. The 3 comes out because square root of 9 is 3, square root of 4 is 2, square root of 4 is 2, and square root of 25 is 5. So we now have 3 root 7 plus 2 root 2 plus 2 root 7 minus 5 root 2. You can only add or subtract things that are alike. 3 root 7 and 2 root 7 are alike. So when we add them, 3 and 2 gives me 5. They stay alike. Leave the root 7 alone. 2 root 2 minus 5 root 2. Again, we're only worried about the coefficients, the numbers out front. 2 minus 5 is negative 3. Leave the root 2 alone. Those will not combine. Now, addition and subtraction, they have to be alike. But on number 4, multiplication, they don't have to be alike. In order to multiply things, you simply, now notice there's no plus or minus signs here. That would change things a bit. But to multiply, you're simply going to combine the things that are alike. 2 and 3 don't have radicals, so we multiply them. 2 times 3 is 6. Square root of 5 and square root of 7 are alike. We can multiply those together. They're both roots. We get root 35, and you're done. Division works the exact same way. You're going to focus on the things that are alike, like 3 and 12. You're going to reduce it just like a fraction. 3 over 12 reduces to 1 over 4. When you divide them both by 3, gives you 1 and 4. The square root of 10 and the square root of 5, put them together, combine them. Root 10 divided by root 5 is root 2. So you can reduce it as well. So on top you have root 2, on bottom you have 4, and you're finished. Next one, again, we focus on the 15 and 3. They don't have radicals. So that's 15 divided by 3, which is 5. Root 2 divided by root 10. Now, this one we're going to reduce because the larger radical's on bottom. We're going to divide top and bottom by root 2. So you can put the root 1 on top if you want to. It's not really necessary. And then the bottom's going to be root 5. So you have 5 times 1, or just 5 on top, and root 5 on bottom. Now, this next step is entirely necessary. If you have a root on bottom, we're going to do what's called rationalize. We want to get that root off the bottom. We've done this in previous classes. To get a root off bottom, you're going to multiply top and bottom by that root. So we're multiplying top and bottom by root 5. On top, these are not alike, so we can't combine them. 5 root 5. On bottom, root 5 times root 5 is root 25. And I would like for you to just note, to simplify that down to just plain old 5. The square root of 25 is 5. Then we can cancel again. 5 and 5 cancel, leaves you with just root 5. The reason these could cancel, neither one of them have roots. If the bottom is a binomial, and we'll just work a few more of these. If the bottom is a binomial, it's not so easy. We can't just multiply top and bottom by root 6. And what I mean by a binomial is if it has a plus or a minus sign. What we're going to do to get rid of this, we're going to multiply top and bottom by the conjugate of the bottom. 3 root 6 plus 2. The top, 3 root 6 plus 2. Now, in order to do this, in order to multiply these out, let me go ahead and skip down and show you how on number 10. To square one of these, again, because of the minus sign, squaring means to multiply it times itself. So we're doing 2 minus 3 root 2 times 2 minus 3 root 2. This is a binomial because of those minus signs. We have to multiply everything times everything. 2 times 2 first is 4. 2 times negative 3 root 2. Again, multiplication, we only multiply the things, we combine the things that are alike. So 2 times 3 is 6. We leave the root 2 alone. We're done with the 2. Negative 3 root 2 times 2 would also be negative 6. Leave the root 2 alone. Now, negative 3 root 2 times negative 3 root 2 would be a positive 9 root 4. And we can clean that up. That's 9 times 2, or just 18, because the 4 comes out. Now we're adding, subtracting. Last step, 4 and 18 gives you 22. These are alike. Again, we plus and minus when things are alike, and that'll be negative 12. Leave the root 2 alone. So we're going to do the exact same thing on this last problem. We're going to multiply top and bottom by 3 root 6 plus 2. We'll do the top first because it's going to be a little bit trickier. So we're going to do 9 root 6 times both of these. 9 root 6 times 3 root 6 would be 27. 9 times 3. And then root 6 times root 6 would be root 36. Now, I'd like for you to get into a habit of instead of putting root 36, you just go ahead and do, that's 6. So 27 times 6. 9 root 6 times 2 would be, multiply the things that are alike. 9 times 2 is 18. Leave the root 6 alone. You're done with a 9 root 6. 5 times 3 root 6. 5 times 3 is 15. Leave the root 6 alone. 5 times 2 gives you 10. So there's your top. On bottom, 3 root 6 times 3 root 6 is 9. And then root 6 times root 6 is the square root of 36, or just 6. Since these are conjugates, if you were to multiply these together, you get 6 root 6. If you multiply these together, you get negative 6 root 6. They're going to cancel. What's nice about conjugates, you don't have to multiply everything times everything. You can simply do what I just did, and then multiply the negative 2 times the positive 2, and you get negative 4. That's the only thing that's not going to cancel. Now let's clean up. 162 is what you get when you multiply these. That combines with 10, gives you 172. These are also alike. 18 root 6, 15 root 6 gives you 33. Leave the root 6 alone. On bottom, you have 54 minus 4, or just 50. Now, you can leave your answers like that if it's not reducible, or a lot of times they're going to split these and write it as 172 over 50 plus 33 root 6 over 50. And if you can reduce, like this does reduce, that's going to be, divide by 2 maybe, that's going to be 86 over 25 plus 33 root 6 over 50, which looks really ugly, but that's okay also for a final answer. Now, again, I can't stress this enough, but if there's no plus or minus in the middle of these, they don't have to be FOILed out like this. If you got negative 5 root 5 and you're squaring that, you're simply multiplying it by itself. You're doing negative 5 times negative 5, or 25. Root 5 times root 5, you're multiplying, you're combining the things that are alike. Root 5 times root 5 is just plain old 5. Final answer there would be 125. So if there's no plus or minus signs, if you would like to just square the negative 5, which gives you 25, and then square the square root of 5, which gives you 5, you can do that. You don't have to FOIL it out unless there's a plus or minus sign.